Hey there, my fellow guitarists. My name is Clint Hoagland, and this is Creating Electronic Music with ChucK. In our last video, we looked into events, which are objects in ChucK that let you force your program to wait for something to happen. We also showed how events could be used to allow us to interact with our ChucK programs in real time. In this video, we're going to look at a specific type of event subclass, MIDI events. This is the first video in the series that isn't for everyone. If you do not own any MIDI devices, and you would probably know if you do own one, be it a MIDI controller or a MIDI instrument, then you won't get anything out of this video. Please feel free to skip to the next one. As we discussed in video number 8, MIDI stands for Musical Instrument Digital Interface. It's a standard that was developed in the early 80s by Dave Smith, president of Sequential Circuits, and later Dave Smith Instruments, and later again Sequential. Prior to the invention of MIDI, every synth manufacturer used their own system for controlling electronic musical devices. This meant that a music studio couldn't easily use equipment built by more than one manufacturer, which was bad for everyone. When Dave Smith proposed a common standard in a paper to the Audio Engineering Society, all the major manufacturers agreed that this was a good idea, and in 1982, Roland released the first commercially available MIDI synthesizer, the Jupiter 6, and the first MIDI-capable drum machine, the TR-909. The official MIDI spec was released in the fall of 1983, at which point other manufacturers started following suit, and now, almost 40 years later, we can still use MIDI as a standard way to control a hardware synthesizer, and as a way for a hardware controller to send messages to ChucK. Under the hood, MIDI events in ChucK work pretty much like keyboard input does. There's a class called a MIDI in, which is a subclass of an event. Inside that is a receive buffer, and in that buffer is some number of MIDI messages. Those MIDI messages are a simplified version of the MIDI message protocol. Really reading a MIDI message involves teasing apart a set of ones and zeros that is usually represented as hex numbers. Thankfully, ChucK handles that conversion for us. What we see instead is a message that contains 3 streams of data. They are members of the MIDI message class, and they're called Data 1, Data 2, and Data 3. All 3 of these are ints. Data 1 will contain what kind of MIDI message it is. Data 2 and Data 3 will contain either the data of that kind, or possibly nothing if Data 1 specifies data that doesn't need 2 more data streams. For example, a note on message contains 3 values. Data 1 contains a 144, which is the code for a note on. Data 2 is the MIDI note number, and Data 3 is the velocity, which represents how fast the keyboard key hit the keybed. Helpfully, one of the ChucK examples can help us figure out what's going on. I've copied it into a script. Let's check it out. So here it has an int device of 0, and so it just assigns 0 to an int here. And then it says if you've got args, then set your first argument to your device number, which is that's an int, and A to I is, I think, alphabet to int. That's another convenience method in the standard library. So what that means is, if you call the thing with a command line, then you can set use an argument to the command line to choose your device rather than using 0. Let's talk about what the devices are on your system. There's going to be a certain number of MIDI devices on your system, and you can identify them. Like, how are you supposed to know what number is what? I have multiple MIDI devices attached to my system. There's a probe function called ChucK -- probe. And it tells you a bunch of things about your system. So it just printed out a ton of stuff. I'm going to make this thing a little bigger. Scroll up. So it tells you a bunch of things. It's got my audio devices. I am using a Roland Studio Capture audio interface, so it's got a bunch of inputs and outputs. So it told me about that for a while. Down here, it's got your MIDI inputs. There's a Studio Capture, and then I have a Motu MIDI Express. That's my MIDI router. So my keyboard is attached to port 1 on the Motu, so it's going to be coming in there. And I just realized that I think that I want to set up my webcam, so we're going to pause this for a second because I want to show you me hitting keys on my keyboard. So back in a second. All right, we are back, and as we saw last time, my MIDI interface that I'm going to be using for my keyboard, which is this keyboard here. This is my trusty Moog grandmother synth, which doubles as a MIDI controller. That is on port number 1 according to the ChucK probe. So the way that we access that is we're going to do ChucK MIDI test, and then the way you add an argument to a ChucK script, which I just figured out, was you put a colon after the script name. So I'm going to say 1. And then MIDI device 1, express 128 port 1. That's exactly what I wanted. That's what my keyboard is plugged into. And now I'm going to press a note. And also let it go. So what that did was, we can see here on our command prompts, and this is what it's doing. It's printing out message data 1, message data 2, and message data 3 to the console. The MIDI event was chucked into now, and when the MIDI event occurred, we dig into the MIDI events receive buffer, get the message, and then print out the data from that message. Data 1, the first one was a 144, and that is a note on event. The second was the MIDI note, which was 60. And the third, data 3, is the velocity. So that's how hard I hit the key. I'm going to hit the same thing again, but very softly. See, that was a 1, a little harder, 99. I'm going to jump up an octave. You would expect that to be 12 above the first one, right? So that is up an octave, and that's what we see. We see a note on of 72 and 114, and then corresponding to each one of our note on events is a note off event, which is 128. And we can see that because I hold the note down, I leave it, and then if I take my finger off the key, we get the note off event, which has the corresponding same note value as the note on event that preceded it. So I could do 2 of them in a row and then release them in an opposite order. So that way you can do some bookkeeping about what notes are currently held down. What else do we got on here? We have this synth has got a bunch of knobs on it, but most of the knobs don't send MIDI. They're wired directly to things that happen in the synthesizer because it's an analog synthesizer. But these two wheels here at the end, which might not be able, now you can see them. These two wheels at the end, this one is a pitch bend wheel, and this one is a mod wheel. The mod wheel is attached to 176, and we can see that, and it goes all the way from 0 to 127 in data 3. So it's the data 1 is 176, and data 3 is notes or is things from 0 to 127. Wherever I move this wheel, it will move that value. And pitch bend is 224, and you can see it's going very rapidly. And pitch bend is actually, this is a little bit more complicated from a programming perspective, so we probably won't use this in ChucK, but because those two numbers combine to become the pitch bend value, because pitch bend is a lot more granular than 0 through 127, so that you can get a smooth pitch bend, which makes that possible for synth manufacturers, but it's going to make things tough for us in terms of numbers. So for our purposes, this keyboard controller has got keys, and it's got a single controller for changing numbers, and we'll be using those in a second. Okay, so what you see here is a variation on what we did in our events video. Our first section here, where we set up our audio chain, it's got a sine oscillator into an envelope, into a reverb, into the DAC. We're going to set our gain, and then we're going to set the envelope 100 millisecond decay, and then 0.1 to the mix of the reverb. We're going to do, instead of using the HID, we're going to use the MIDI in and MIDI message that we described a little bit ago and what we used to print out to the console. Using the same idea here where we're going to use the 0 device by default, or we'll use the one that comes in as an argument. And then we're going to exit if we can't open it, and then we're going to print it to the console. I made a play beep function here that we spork in here if the message data is 144. So we saw that that was a note on. And then we will spork it with message.data2, which we saw was the note value. And if we run that, okay, so now what has happened is that MIDI has been chucked into now, and it's awaiting an event. If I hit my key, we get a sound. If I go. Now, right now, this doesn't play chords, and the reason why is because we only have the one sine oscillator. So I'm going to stop this, and I'm going to take this part here, actually all of this, I'm going to copy it into our play beep function. Save her up. And this isn't going to be what we want, but I'll show you why in a second. Launch it again. So we lost our reverb tail. And the reason why is because this function ends and the reverb goes out of scope at the end of this function. So we want that not to happen. So what we're going to do to make that not happen is we're going to cut this out of here and set it back up at the top like before, and we're just going to chuck our oscillator into the reverb, save it up, close my process, launch it again, and now we can, oh, you know what, I should turn down the gain because it's going to be too loud. I'll turn the oscillator gain down to 0.15. How's that sound? And launch it again. If we want to, we could make the decays last a little longer. Let's make this 300. Make 300 go into now. And then launch it again. It's waiting. So now what I've done is I've added message.data3 to the play beep function, and up here I've identified that argument is being called velocity. And on this line here, I changed it so that our oscillator gain in our play beep function is 0.5, and then I multiplied the velocity times the velocity divided by 127. So that will get us 0.5 basically from 127th of that to all the way to 1, right? So let's see what we get when we play this one. It's listening. So I got the ability to play louder or quieter. Okay, and lastly, now I've added a low pass filter before my reverb, and now my play beep function, the oscillator goes into the envelope and then into the low pass filter. I've changed my oscillator to be a saw oscillator. And there is a default value of 500 going into the low pass filter's frequency, and I threw a 5 into its resonance or Q value. So, and then down here, I didn't have to change this other than chucking the envelope into the low pass filter. But in our MIDI event loop, now, in addition to checking messages to see whether they're node ons, which is 144, I'm also checking to see if they are mod wheel events. And if it is a mod wheel event, then indicated by a data 1 of 176, then I multiply 4,000 by data 3, which will be a value between 0 and 127, and I divide that by 127 so that 4,000 is divided by some fraction of 1, and then that gets chucked into the low pass frequency. And let's hear how that sounds. Has a tendency to clip. So we can change the filter frequency using that mod wheel. This is kind of fun. All right, the last thing I want to show you today is how to control MIDI hardware from ChucK rather than the other way around. So what we have here is instead of a MIDI in event, we have a MIDI out, which is not an event. It's just a way to control your MIDI hardware. I called mine GMA because I'm going to be controlling my grandmother synth here. That happens to be on output number 2, which I found out from doing ChucK probe. And then, so I make myself a MIDI out called GMA, a MIDI message called MSG, an offset of 48, which we've seen before, and then a chord with just 2 things in it right now. And then I've got a function called play grandmother, or play Gma here, which just takes a note, and I'm logging what the note is to the console. And then I chuck a 144 to the messages data 1 stream, which, as we know, is the note on. The note, which is a MIDI note number, is going to go to message.data 2, which we know is for MIDI notes. And then 127, which is the max, it goes to message.data 3. You have to send something to data 3. You can't not send something because it won't make a noise if you do that. And then you send it via the hardware. You send the message to the hardware. And now I'm chucking 50 milliseconds into now. And then, so 50 milliseconds later, I'm going to send a 128 to, I'm going to stuff that in the messages data 1 stream. 128, as we saw before, was the note off message. Again, the note number goes to the second data stream, and 127, which is just picked at random but isn't nothing, goes to data 3. We send it again, we send this message to the hardware and wait 50 milliseconds. And then down in here, I am just randomizing the position and then picking a note and then sending that up to this function. Let's hear what it sounds like. You're only going to be able to hear it through my microphone because the routing on my computer is kind of complicated and my screen recording software doesn't hear it through an input, so you're just going to hear it through my microphone, but hopefully you'll be able to hear it well enough. Oh, did that wrong. Go down here. So one problem that you may have while doing this is that it may have stopped the execution while it was doing note on and not note off. And in that case, you might have to send a MIDI all notes off message to your synthesizer. On this particular synthesizer, you do that by holding down these 3 buttons for more than 1 second. So now that I have, okay, now it's not stuck anymore. So that sounded pretty cool. Let's try a little major 7 chord, just because you know I love them. And let's go all the way. Well, it's randomized between 3 octaves or 4 octaves. I don't know. And hear what that sounds like. Let's turn that to that and go down here for a second. That's kind of neat. It sounds kind of BBC radiophonic workshop. So yeah, that's how you play MIDI hardware with ChucK. It's very simple once you understand what these data streams are. It's almost as if they designed ChucK to be easy, make this easy, which they did. Yeah. As you can see, ChucK makes it easy to control physical hardware via MIDI. It's kind of fun to be able to control this stuff from your command line without using a digital audio workstation. Using the ADC, you could also record what your hardware is doing and use that digital audio in further compositions. In this video, we talked about using MIDI to communicate to ChucK from your MIDI hardware. In the next video, we'll talk about the instruments of the STK.